What a nice day for a vector calculus lecture. Well, I think it's about time now. Alright, let's go ahead and do it. Folks, welcome to Vector Calculus. Welcome back to the next lecture in vector calculus. Today we're taking a look at Alright folks, so as you can see, I just died because of a missile explosion, but we can actually fix that just using the mathematics of hyperbolas. So let's go ahead and check it out, okay? So here's some of the facts we know, okay? Number one, we know that there was a missile, but we don't know its location. That's our goal. We have to figure out where the missile was just before it hit me, like where it came from, where was its origin, okay? So that's our goal. And here's some of the facts we know. There were two centers, two detectors, okay? Two detectors, and both of them are missile detectors. Unfortunately, they failed to detect any missiles, and therefore I died. But if they did detect the missile, one of them, let's call them A and B, let's call the detectors A and B, the B detector would have detected the missile 2 seconds before the A detector. That means, of course, the missile was closer to B than it was to A. The question is, how much closer? Let's go ahead and check it out. First and foremost, what do we know is that the detectors A and B, the missile detectors, are 1 mile apart. They're 1 mile apart. We also happen to know that missile detector B detects the sound of the missile 2 seconds before missile detector A. Okay, so if we go ahead and actually put our coordinate plane right here, where the origin is going to be the center of some kind of a hyperbola, then we know that our missile is somewhere on the right branch of this hyperbola. Here's our missile. Now our goal is to actually get the equation for this hyperbola so that we can kind of get a sense of where the missile was launched from, okay? So, what's some of the information we know? Well, number one, we know that the missile detectors are separated by 1 mile, right? So that means, what is our C value? Remember, C is the distance from the center of the hyperbola to one of the foci. Well, that distance is simply going to be 1/2 of a mile. And of course, what's half of a mile? Well, that's simply going to be 5280 feet over 2, okay? And of course, you can go ahead and calculate what that is on your own, okay? And as a matter of fact, we've got the values right here. That's going to be 2640 feet. And so that's going to be our C value, okay? That's going to be our C value. Now, we have our C value. What do we do with it? Well, we can actually do some interesting stuff, okay? We know that missile detector B heard the missile 2 seconds before missile detector A, right? So if you go ahead and construct these two auxiliary lines, what does that tell you? That tells you that the distance from missile detector A to the missile is D2, and the distance from missile detector B to the missile is D1. That distance, let's call that distance D2 minus D1. If you subtract these two distances, that's always going to remain constant, no matter where the missile is on the hyperbola. Okay, and as a matter of fact, this is equal to 2 times our A value. Now, remember that the difference in this distance is actually going to be 2200 feet. Now, why is that? That's because, remember, that the speed of sound travels at 1100 feet per second, right? That's the speed of sound. And we know that missile detector B heard the missile 2 seconds before the missile detector A, okay? So 2 seconds before A. Now, because it heard the missile 2 seconds before A, and the speed of sound travels at 1100 feet per second, we know that the difference in distance has to be 2200 feet, is equal to 2A. And thus, if we divide both sides by 2, we can actually retrieve our A value, which is going to be 1100 feet. Now we have our A value. What about our B value? Well, that's not too bad. Remember that for a hyperbola, C squared is equal to A squared plus B squared, okay? So we can have, what is our C squared? That's 2640 whole squared is equal to, what's our A at 1100 squared, plus what is our B? It's B squared, right? Now, if we go ahead and just use the Pythagorean theorem, what are we going to get? Well, it's pretty simple. It's going to be B is equal to the square root of 2640 squared minus 1100 squared. And now we can actually just put this in the calculator. Let's go ahead. We've got the portable calculator right here. Let's see if this thing actually works. Right. So, okay. So let's go ahead and go to Chrome. And let's calculate what this B value is going to be. Okay. So someone in our audience, go ahead and calculate what this is going to be. Let's go ahead, calculate it. Go to Google and type in 2640. Okay, math in the classroom. 2640 minus, what's 2640 minus 260? 2640 minus 24. Let's check out what that is.
2380.
Okay, so what is this gonna be? Square root of 2640 squared minus 1100 squared. What is that? Okay, go ahead and check it out. Let me know what you get. Plug this in your calculators. I'm also going to be plugging it in my calculator just in case.
That
so
gives you 6, 9. 6, 9. Are you writing it down?
Yeah. Can you?
6, 9.
Okay.
6, 9, 1069.
6, 9 again.
Okay.
6, 0, 0.
Okay, that doesn't make sense, but let's go ahead and check if that's right. 2640 squared minus what? 1100 squared.
Yeah. And then 1, 2 minus.
Oh, actually I got a different answer. So let's see what I got. We're going to end up with 2399. So our final answer is going to be I see. So basically our final answer will be 2400 feet. Now we're still not done. We're almost there, but we're still not done. But we're on the last step. So what's the equation of our hyperbola going to be? Well, it's simply going to be x squared over, well, what's our A value? Well, that's going to be 1100. Square that minus y squared over what's our B value? That's going to be 2400 squared. And that's all going to equal, what's all of that going to equal? That's going to equal 1. But be careful, because there's a small discrepancy here. If we have this, that means our hyperbola is horizontal, okay, which is actually correct. And folks, that therefore is the equation of our hyperbola. Thanks for watching, and we'll check you out next time.